Okay, so in this example, I'm going to show you how you can almost always find the area between two curves, even if you don't have a graph. So we're going to just basically skip the first step and just jump straight to the second step. So we're going to set these equal to each other. Now, before we can do that, though, we need to move the 1 over here to the right side. And so now we can set 2y equals to y minus 1 squared minus 1. Okay, now we solved this one, so we'll expand y minus 1 squared. So this would be y squared minus 2y plus 1 minus 1. And so that gets rid of those 1's. And so then if we bring all the y's to one side, we would get y squared minus 4y equals to 0. So we get we can factor out a y, and so we get two solutions. Y is equal to 0 and 4. Okay, so then that means that these two intersect. Now, remember we talked about this, that when you're, normally you set this up, and so you would go, since there's only two intersection points, and that means that there's only one integral, but then you have to figure out, well, which one's on top and which one's on bottom, or in this case, which one is more right of the other. But remember that we said that if we do it by accident backwards, we just get the same exact thing, it could potentially come out to be negative if we flip-flop them. So what we're going to do is just do it randomly. So let's just say I'm going to do 2y minus, and then this one, minus y minus 1 squared minus 1 dy. So what's going to happen is if I get a positive number and I did everything correctly, then good job, thumbs up. If I get a negative number, then the area is just the positive of that one. So, okay, so let's continue. So let's simplify this a little bit. So we have the integral from 0 to 4 of 2y, and then minus, if I FOIL this whole thing out, I would get minus y squared, and then plus 2y, and then this one you would get, so here, why don't we do this? This y minus 1 squared would be y squared minus 2y plus 1. But then minus 1, those two are going to cancel out. So that's all I have left over, dy. Okay, so then I'll get the antiderivative, which is y squared over 2 minus y cubed over 3 plus 2y squared over 2. I guess I should have combined those two, but oh well, I guess I can do it. So this would be 2y squared minus y cubed over 3, evaluated from 0 to 4. And so then this is equal to 2 times 4 squared, that's 32, minus 4 cubed is 64 over 3. And so this is equal to 32 thirds. Okay, so here we have the area between sine of x cosine squared x between pi over 4 and 3 pi over 4. So we have our picture here. And notice that they intersect, but they only touch right there. So I don't really need to find the intersection points. I just need to set up the integral, and I'll go from pi over 4 to 3 pi over 4. And top minus bottom, so that means it's going to be cosecant squared x minus sine of x dx. Okay, and so then I just need to find this integral. So cosecant squared, the antiderivative of that is negative cotangent of x, and the antiderivative of negative sine x is going to be plus cosine of x. And this is going to be evaluated from pi over 4 to 3 pi over 4. Okay, so then I have negative cotangent of pi over 4, or negative cotangent of 3 pi over 4 plus cosine of 3 pi over 4. Okay, and then minus cotangent of pi over 4 plus, almost got you there, negative cotangent of pi over 4 plus cosine of pi over 4. Okay, so cotangent of pi over 4, let's go here to our trusty unit circle. That's right here in the second quadrant, right? And so tangent right here is equal to, since sine and cosine are the same except for the opposite sign. So tangent is equal to 1. So cotangent is equal to, well, I mean negative 1, I guess, because tangent is negative in this quadrant. And so this is equal to positive 1. So you have the minus and then the negative 1. So that makes that positive. And then plus cosine of 3 pi over 4. That's minus root 2 over 2. And then minus, again, negative cotangent of pi over 4. That equals to positive 1. So then we have minus 1. And then plus root 2 over 2. Okay. So then this is equal to 2 if I combine this one and then this plus 1. And then I have minus root 2 over 2 minus another root 2 over 2. That's going to be simply minus square root of 2. And that's it.